So this year is our lower 6th term 1 physics project. Our group members include Avinash, Deosaran, Danielle, Tannis, and Samuel Rogers. We decided to investigate an object in freefall, and it's important to note that objects in freefall are influenced only by the downward force of gravity. They accelerate towards the Earth at a speed of 9.81 meters per second squared, which is usually rounded off to 10 meters per second squared. It is also important to note that objects in freefall experience no substantial or significant amount of drag or air resistance. We decided that Newton's first law, which as you can see here, could have been applied to objects in freefall. What you see in here is exactly what Sir Isaac Newton said, and what it basically says is that if a body is at rest, it remains at rest, or if it is in motion, it moves with uniform velocity, examples constant speed in a straight line, until it is acted upon by a resultant force. So when the ball is being held, it is at rest, therefore the airspeed is 0, but when it is released, the object accelerates. Why? Because it is being acted upon by an unbalanced force, which is gravity. But when the drag is equal to weight, this is when the object no longer accelerates but holds a constant velocity, also known as terminal velocity. So basically this here is an object free falling, the object being a wind ball. As you can see, I've already placed in the axes as well as the scale. The object fell through a distance of 1.45 meters. And just to give you an idea how I use tracker, I followed these steps. So basically that is what I did to obtain the graph. And this here is the graph I obtained. As you can see, this graph is a curve. And by the way, it is a distance time graph. This slope is increasing. Therefore, the velocity is increasing with time. The object is accelerating. And due to the shape of the slope, it indicates that acceleration is constant, which means that this method of tracking the position of the ball as it changes with time is accurate. Therefore, the results are accurate. Probably if the wind ball had fell through a greater height, we would have been able to see where the object reached terminal velocity. Further analysis of the graph indicates that the equation in y equals to mx plus c form indicates that the gradient is 3.08 and the y-intercept is negative 1.57, which is slightly off, but as indicated here in this row, that it starts from the origin. So the y-intercept should actually be 0. So these results are accurate based on the fact that the results should